Chemical engineers rely on their knowledge of mathematics and science, particularly chemistry, to overcome technical problems safely and economically. Plastics make life better, healthier, and safer every day. Plastics are used in cell phones and other electronic equipment. They are used as insulation that makes buildings energy efficient. Also, plastic in packaging help keep food and safe and fresh. There are thousands of different kinds of plastic and formulation. Primary processes that are used in plastic production are polycondensation and polymerization.
Life cycle of the plastics starts with extracting raw materials. Then plastic resin is produced. End product is fabricated. End product is packaged and distributed. Then the final product is used and sometimes reused. We came to the end of life? We don't think so. We can recycle the plastic waste to produce new plastic products.
Here, you can see a basic block diagram for PET production. Raw materials are mixed in a tank. The resulting paste is then sent to esterification tanks to increase the oligomer molecular weight. Low molecular weighted PET oligomers are sent to a wiped film evaporator to increase the molecular weight. After molten polymer exits the evaporator, it is pelletized and packaged. Process safety is important in plastic production because it requires high process temperatures. In addition, raw materials that are used in this industry are easily flammable and carcinogenic.
We can see how important and versatile the plastics are. Let's see if there are any downsides to plastics. Plastics are made from liquid petroleum gases, natural gas liquids, and natural gas. Oil and gas are non-renewable resources. What's more, the extraction of these fuels and natural gas is very dirty because of pollution and water-intensive processes with toxic emissions. Before becoming plastic products, the carbon in fossil fuels is polymerized into tiny raw plastic pellets, sometimes nicknamed nurdles. These nurdles are shipped all over the world to factories, where they will be processed into products. But before the nurdles reach their destination, many of them end up in the ocean. The nurdles are accumulators of hydrophobic pollutants, and they also endanger marine animals. During the manufacturing process, additives are combined with the plastics to affect their qualities, and some of these chemicals are pretty harmful. Many of the post-consumer plastics end up in the ocean. Most fossil-based plastics and even some plant-based plastics will not biodegrade. They are, however, photodegradable, which means that if they are exposed to light, they will degrade into smaller pieces of plastics that are not only swallowed by marine creatures but become embedded in the very bottom of the food chain and thereby poison our food with toxins.
The negative environmental effects of plastics increase the demand for more efficient waste management practices, remediation technologies, and recycling systems for plastic waste. To minimize the impact of plastics, researchers are focusing on waste management models and the creation of a circular economy. Remediation technologies are creating processes that convert plastic waste into useful energy sources in developing nations. For example, we can produce a fuel derived from the pyrolysis of plastic waste, and it could serve as an alternative to conventional diesel. To decrease the environmental footprint of plastics, engineers must optimize the recycling and upcycling processes associated with these materials. Mechanical recycling, co-gasification, liquefaction, and methods such as pyrolysis, hydrocracking, degradative extrusion, and catalytic cracking can be used.